Okay, Scott, I know we're 45 minutes in and finally introducing you, so I apologize that for you, but it's better than doing 20 minutes of intros at the beginning. So tell us a little bit about yourself and your company, what you do, and we're going to segue into compliance and inspections, but you got the mic.
All right. Thanks, folks. Scott McGowan, CEO of Precision Aerial. We've been in the drone space for about 7 years, which oddly enough makes us kind of ancient, I guess, in this industry. But then again, 6 months is a long time here. But we're a tier one service company. Tier one meaning we were original 333s. We've been vetted by multiple vetting associations. We fly for a lot of the oil and gas majors. We primarily fly LiDAR and photogrammetry, although we do have methane capability, thermal capability. And I would say that right now, one of the main things I've really been pushing for the last 3.5 years has really been kind of to get to where we are right now, and even having the discussions we're having today, which is more of the digital twin, the 3D modeling, the use of LiDAR and the combination of LiDAR point clouds with photogrammetry. Because that we're seeing that more and more, and then COVID has really accelerated that in, using more remote autonomous workflows to reduce the number of people in either dangerous environments or controlled environments, especially right now, if you're in any of the plants or the refineries, they're all working with reduced workforces. Many of them are trying to keep just their own people inside. They've reduced the number of vendors from outside that are allowed inside. And one of the good things about what we do is we're generally guys that are very happy to get tucked over in the corner or even outside the facility. And then we can use our drones to go in and collect the data. And that way, we can do a lot of work in a short period of time. We can collect the data that's necessary for the deliverables that they require. But we massively reduce the number of crews that are going to have to permit, as the training that's been brought up a couple of times. And I think the 700 hours is probably conservative, but yeah, it's endless. And so, you just reduce that massive amount of liability they have, maintaining, the permitting of the people, keeping track of the people, all the search you need to go in, all the training you need, the site specifics you need in the morning, the meetings at 6 o'clock. A lot of that stuff gets greatly reduced. And, we have found that generally speaking, we can go in one of our work days and do the equivalent of 2 weeks of what normal crews would be doing from a survey perspective or an inspections perspective. And I think that, again, because of COVID, the ability to do those things with less people in their facilities has really been an advantage. And it's something that I think that, once COVID's over, I think that some of the stuff may remain, just like we found that working remotely using things like Zoom may become more of our workflows permanently. I think that you're also going to see more autonomous and remote solutions in a lot of these workplaces, even after COVID's done.
Yeah. Talk to me about 360 versus your traditional imagery. What's the difference? What's the value? We were talking about some inspection stuff just the other day. What can we expect when we throw a 360 camera on a drone as opposed to the traditional imagery that you're taking? What value do we get?
Yeah, that's a great question. And so it's really quite simple. If we go out and let's just say that we use a traditional drone and we go out and we film some 4K video, or we take some high resolution photographs, they're very useful. They're great, but they're kind of single linear. You're basically only seeing what is captured within that frame straight ahead of either the video camera or the actual camera. So if I take a picture of the side of a tank, that's pretty much the area that I'm going to see is that field of view. If I do the same thing with 360, I can now pan all the way around. Now on the outside of a tank, that's going to allow me to go up, top, down, left, and right. So you're kind of losing 180 of it because you don't really need it, right? Because you're looking at the tank. But then if you fly on top of a tank, on a collapsible roof tank, you can fly down inside it, or in a power plant when you're near stacks or you're near any kind of an asset. With 360, you can position the drone in a place where now, once you capture that data, the individual looking at it can look at all the different angles possible, which, I mean, drones never going to capture that. Drones can't shoot in all those different directions. They're mostly generally just linear on oblique shots or straight down below. A few can shoot straight up, but with 360, you don't even need to worry about that. You can capture all that. But the other thing that's even more extraordinary about 360 is not only do you have that ability to pan all the way around and look at all the different angles, but then once you find something that's of interest, you then also have the capability to zoom in on it. And again, that's combining a number of different things that you would try to do with one drone, all in one. And so, we're finding now testing, some of the solutions, with video and with photography with our drone it's a really, really usable tool. And I think that even because, you can even, you can experiment with extending the camera below the drone. I mean, you can go to like a 3-foot extension below the drone, a 5-foot extension below the drone, or have it more flush mounted depending on what you want. But that's getting that 360 camera down into areas that you're going to collect some great visual data, but it's also areas that human beings just are not going to be able to get to. Or if they can, they may be, places that might be like a class 3 climb or something that's considered, pretty much extremely dangerous. So, why bother? Especially
and whenever you have like overhangs and that sort of stuff, traditional overhead photography doesn't always capture everything. With the spherical images, we can get in and under things, can't we?
Well, if you look at your, almost any drone that I'm aware of, and I pretty much keep on top of it, other than the instance where DJI has a few that you can mount a camera on top. But most drones are going to be essentially, 90 degrees left or right, and then straight down. So you've got just that very basic quadrant that they can capture photos from. So, if you have anything that's above the drone, you just can't capture it. Because the cameras just don't point up. And if they do, if you can rig it, then they're going to be pointing up into the blades. You're not going to see anything anyway. So with 360, you can fly obliquely right next to an asset. You don't even have to really be that close because the cameras are so good now. But you're going to be able to get up inside things and look at everything under an overhang. I'll give you an example. Like on tanks, they have, they have like a wind curtain all around the top, which prevents you from seeing the top from the bottom or the bottom from the top. But with 360, you can see above and below it all the way around it. And it's going to be really useful. We've flown some pipeline projects with them where you can see everything in the trench, before they lay the pipe, after they lay the pipe, flying right-of-ways, or actually 4 years ago for the city of Houston, we flew drainage ditches for them. We were trying to find out how much of those drainage ditches were being constrained after all the storms. And normal photography would do a pretty good job, but when we flew 360 down the middle of the drain, throughout that video, you could sit there and toggle on both sides and see all the way up both banks on the other side and see what was above the banks on both sides, or you could then look straight down into anything that was below in the ditch. But then again, if there was something that was interesting to you, unlike a normal video, you could then stop it and zoom in and look at that actual item. And if you wanted to,
especially subterranean stuff. I mean, it's not like you get an option just to kind of resurface it, or, you have to dig. So having that captured has got to be really valuable.
Yeah, it just, I said to you the other day, man, it always reminds me of those spy movies where they like drill the hole in the floor and the little camera snakes up inside and they can see everybody in the room. But I mean, that's kind of what you can do with a 360 camera, because you can get it in places, with a painter pole, you can get up into areas that no one's ever going to be able to climb into.
Yeah.
No, it's great technology. I think there's just going to be so many uses for it.
Great. Appreciate that. And I got a couple slides here from some of the, heat mapping that you're doing and this sort of stuff. So, and anyone's looking for drone work done, I think Scott's one of the leaders here, do some pretty cool stuff.
Yeah, that's just straight up LiDAR. What we're doing is the containment berms of a tank facility. So you can see in the upper right heat map, you can see where the break in the berm was from a storm. Then it was 3D modeled down to the left with accurate 1-foot contour break lines. And then that lower right is the entire facility that's had everything. That's actually a small plant with a lot of storage tanks that everything has been stripped off the surface. And that's the heat map of the actual dirt surface of that entire facility.
Excellent. And, for those that are watching, what's the connection, with Visual Plan, any type of diagram imagery, whether it be thermal or not, these are data sets that we can potentially bring in our software, BIM, LiDAR, et cetera. So I think there's always this merge. It's not, as Sam brought up at the beginning, the presentation here, it's not one or the other technology, it's what we need it for. So being able to kind of see all these things in a single interface is super, super helpful. And a couple more slide shots of the projects that we're doing with you and the inside. It's really fascinating when I talk to your client and they say, well, what do you guys typically get for a deliverable today? 100-page engineering report with screenshots of LiDAR and other things. And I was like, wow, that's it. But these guys have never been in the tank and now they got to go in and fix things, welds, corrosion, all this stuff. Like, that's amazing what we're doing here. It's giving them a complete walkthrough. They can look at things that are really hard to detect because we got hundreds of photos in here, right?
And just quickly, Kelly. So what you see there is that's actually that was a tank that had a fire. As you can tell, it had some considerable damage. It was unstable to have anybody go on at that point, but they needed to know, have an idea of what the surface of the tank looked like. So that was basically a LiDAR point cloud that has a photogrammetry overlay, and it was made into that 3D model. And you can obviously see that there's quite a bit of damage to the roof and some to the sides. And and so that gave them those are just a few shots, but you were able to basically inspect that whole tank because in the software they would spin around, and we actually 3D printed that tank out as well for the client, which was kind of cool.
Cool. And then we were working with the engineers that were doing the inspections, and they actually were recording their recommendations through video and tagging their video recommendations to the repair team so that they knew exactly what they need to do. It's a little different when we look at tasks by text in a project management tool, but now kind of making this more kind of engaging, that we have a 3D tour, we have video, we're really talking through the process here. So I thought that's really cool in terms of turnarounds and repairs. So quick segue here, I think it's interesting now we're kind of talking about all these different applications, and it's very interesting to see who really needs to see your facilities and at what stage. And I think that as we're kind of getting through this, it's not just the engineering or design teams, as Sam was talking about, it's the owners, right? As Kelly's saying, there's a variety of subject matter expertise that can be valuable to the process, right? So I think when we kind of look at visualization, we kind of look at, well, who's involved, who gets to see it, who needs to approve it, confirm it, who needs to protect it, who needs to prevent and fix it, and even on a training aspect, who needs to teach it, learn it, and even just finding small assets on big